So good afternoon, my name is Mark Taylor. I'm a Senior Digital Construction Manager working at Royal BAM Group in the Netherlands. I'm here to talk a little bit about manufacturing and construction at Royal BAM Group. So Royal BAM Group, 7.2 billion turnover construction organisation, headquartered out in the Netherlands, around 20,000 employees working worldwide. Our main focus areas are in the UK and Ireland, the Netherlands and Germany and Belgium, but we work in worldwide on projects as well. We work in civil engineering, in rail and tunnelling, and also construction and property, so building stadia and hospitals and apartments and the like. So I'm going to talk a little about industrialised construction. And industrialised construction is the application of manufacturing techniques in the built environment. And a recent industry report identified sort of 5 mega trends in this area. And I'm just going to focus on those areas and show what we're doing around the business in relation to these. So big data analytics. So in construction, we're using big data analytics to look at things like, here in this example, we're surveying roads using like a Google camera, Google truck. And this is to support the maintenance programs we have in the Netherlands. So we don't need to go out and physically check the road surfaces. In robotics and automation, we have a number of projects, but one of the more recent ones is Hinkley Point project in the UK, where we're using machine guidance systems for installing, in this example, anchors, and this allows us to do this based on data from the designers going straight into the machines and placing the anchors in the right positions. Prefabrication, so a large component of industrialised construction. So in prefabrication, we are producing full volumetric modules for housing in Ireland. We're also creating volumetric apartment buildings as well. You know, these are 90% complete before they're delivered to site. And also using panelized construction in our Sky Factory concept. We've been doing this for a number of years, where we basically bring everything together in a factory environment that is lifting over the construction site. So as you can see here on the top left, our workers are inside a dry space, installing the deck, ready for the next lift of panels onto the deck, which are here in the bottom left-hand corner. We're also doing multi-trade assemblies using for MEP into our projects. So we have we coordinate the design digitally, and then we fabricate all the modules and install in sections on site in our projects. So IoT, this is a couple of bridges that we installed in the Netherlands as well, and we're now hooked up to those bridges, streaming data live on their on how they're being used, and this is enabling us to have implement better work maintenance regimes, because we understand how the bridges are being operated, and if they're being operated outside of their designed envelope, so that we can make adjustments in how they're operated, or how we train staff to operate them in the future to avoid them being stuck open or something like that because of a a problem with them. And then in additive manufacturing, so this is the newer focus for us in BAM. We are looking at additive manufacturing in the construction space, and particularly 3D concrete printing. So we design, we print, and we assemble. So we have a 3D concrete printing factory based out of the Netherlands. And this is born out of years of development. So this started way back in 2000 with our materials partner, Saint-Gobain, where they developed the mortar mix for 3D concrete printing. Fast forward to 2017, we installed the first 3D concrete printed bridge in the Netherlands, a cycle bridge. 2018, we started working on housing. 2019, we opened our factory in the Netherlands. We also started to intensify our investigations into how we fully digitalize our factory setup and ordering processes. And we started a commission on the world's longest 3D concrete printed bridge, at about 30 meters long also. So this is the bridge in Geermet being printed. It was based initially off some sketches where we were looking at how to reduce material in the bridge deck and provide the strength we needed. And this is the bridge installed in situ, being load tested. And then this is it on opening day. So it's now fully been in operation for nearly 3 years, or 3 years. We also, as I said before, we've opened the world's first production location for 3D printing of structural concrete elements. So this is now churning out all sorts of elements for different projects around the world. So why 3D concrete printing? So while we see, as I showed before, in design and preparation and in monitoring and in management, it's full. These environments are very digitized, and we saw in the execution phase that we're still using very traditional methods out on site. So we saw an opportunity to improve and adopt more manufacturing type processes, even in the structural development of the project. So we have in this process, the advantages are we have one model from the design to the construction. So we're not reinventing the wheel constantly. We have sort of free form and affordable design because we're printing it. We don't need expensive molds and to create these different shapes. We only put the material where we need it, so there's less waste in terms of materials only printed where the strength is needed. And we can also add in, not only do we have the compressive strength of the concrete, but we can add in steel cable in each of the layers to create tensile strength in the elements being printed. So a new way of designing. So now we design the object, taking 3D printing into account. So we work with customers and clients at an early stage to look at how we can solve a problem rather than build 3D concrete printing into our process. We'll print a prototype and we'll test and validate the prototype and adapt to suit anything we see in our testing phase. And then we move to production and installation. And once we've designed one element and the principles are set, we can then use that multiple times for different elements using the same principles. So we use parametric design for this, so we can mass produce unique designs. So our factory, this is an example where we're using the parametric design in the north of Holland. So we've got 4 bicycle bridges that we're going to print. We've designed, we have, our partners have designed the bridge deck using a parametric model. This allows us, based on certain constraints, to have multiple designs for each of the bridges, but based on the same principles. So this is one version, and then this is all 4. And all of these bridges are fundamentally the same. They just they've just been stretched or made wider or longer to suit the condition that they're in. But they're working within the same design constraints and which are in the parametric model. We've also, as I mentioned previously, started work on the longest 3D printed bridge in the world. This is a visualization of the bridge. It will be printed in segments like this and installed on site. So this is the first segment that we test segment. So this is the one that we printed and tested. This is in our factory, load tested. These are the columns. These are installed on site and filled full of concrete and rebar so that these are basically a formwork solution. This is the base where the bridge will be installed, with the piers being cast. We're also doing more sort of basic stuff in terms of this is a retaining wall within a highway. This allowed us to install it, you know, fairly complex shape very quickly within a tight site next to a highway. So we, you know, there was a reduction. The costs were the same as doing it traditionally as they were doing it with the 3D concrete printed method. But we saw a reduction in labour and a reduction in leading time, which then means we're on site less, and we're not putting. We've got a shorter road closure, and our operatives are not in an unsafe environment any longer than they need to be. This is an example of some head walls that we've printed in Driebergen Zeist, and this is usually these would have to be cast in several lifts and using fairly complex formwork. In this example, we have printed the formwork, the head wall, sorry, in our factory in segments, and then these are craned into location on site, and then they can be backfilled straight away and put into operation much quicker. We also have standard parametric components that are run through the factory. So this is a staircase that we, a slope stair wall on our rail projects. So the site teams will call the office, the factory, and provide the dimensions for the stair. We'll stretch the stair to suit those dimensions and then quickly print a slope stair. And then these are installed on trackside to allow maintenance access and access to project sites in a safe way. This is an example of street furniture, actually, and it's the first UK asset in Network Rail's infrastructure that has been 3D printed. It's a bench down in Dawlish. So we're starting to bring these systems into different markets. We've also just completed a project in Belgium, and this is a swimming pool. So very complex geometry for the swimming pool. Printed the swimming pool liner, and then this was just lifted into position on site, and then tiled as a finish afterwards. And this is it on site, put into place. So our latest project is a milestone housing project in the Netherlands. Again, working with our partners, Vitamine and Boss and Weber, we've developed the concept for these houses and tested the solution. So we have printed some of our largest elements to date. As you can see, these are printed in the factory in segments on lifting slabs. So once the elements are printed, we then crane them out of the factory onto transport and take them to the site in sections. So I think the highest segment is up to 3 meters tall in these pictures. And this is the factory running and printing the wall sections. And then these wall sections have ties in them, and then they're filled full of a foamed insulation so that they're fully insulated panels once they arrive on site. So this is the factory, and this is our flying factory system. So we also have a setup that we can take to different locations, and this is a conference in the United States. So we have used this setup for demonstrations to customers and clients, and also we use it for our design development topics as well. But in the future, maybe something like this system would be used on project sites as well for printing in elements in situ. So thank you for your time, and I'll see you on the panel.